Hey everyone, and welcome to Podcast My Paper, the show where we break down academic research and make it accessible to everyone. I'm Tom.
And I'm Emma. We're your guides to the fascinating world of scholarly articles, minus the jargon.
Exactly. Today we're diving into a topic that was super relevant not too long ago, but is still very relevant today. The role of 3D printing during the COVID-19 pandemic.
Remember those early days of the pandemic? It felt like the whole world was scrambling for masks and other protective gear.
Oh yeah, I remember trying to find a mask anywhere, even online, and there were none to be found. It was crazy.
Well, in today's episode, we're looking at two research papers that examine how 3D printing stepped up to fill that need and how makers and manufacturers around the world use this technology to create personal protective equipment, or PPE, and other essential items.
So we were talking face shields, masks, ventilator parts, basically anything that could be printed to help fight the virus and support healthcare workers and others that needed it.
Precisely. These papers offer a really interesting look at how a decentralised digital technology like 3D printing could respond to a very real-world physical crisis.
I'm really curious to see what kind of lessons we can learn from how people innovated and collaborated during that time.
Me too, and also to see how we can apply those lessons to future challenges. Turns out, even today, 3D printing is used in all kinds of areas, from helping build houses to even printing food.
So buckle up, listeners, because we're about to podcast my paper on the amazing world of 3D printing in the face of a global pandemic.
Let's get started. So, Tom, let's set the scene a bit more. What was actually going on with supply chains that made 3D printing so necessary?
It was a perfect storm, really. The COVID-19 pandemic created unprecedented disruptions to traditional supply chains all over the world. Demand for PPE and medical equipment just surged overnight.
Yeah, I remember hearing stories about hospitals completely running out of masks, face shields, and even basic things like swabs for testing. It was terrifying.
Absolutely, and it wasn't just the increased demand, but the geographical lockdowns made everything even worse. Factories shut down, borders closed, and transportation was severely limited. It was incredibly difficult to move goods around.
So you had this huge surge in demand combined with a massive breakdown in the ability to actually produce and distribute these essential items. Talk about a crisis.
Exactly. Traditional manufacturing just couldn't keep up. So where does 3D printing fit into all of this?
Well, 3D printing offered a really unique solution. It allowed for rapid localized manufacturing. Instead of relying on these complex global supply chains, you could literally print these products right where they were needed.
That's right. Think about a hospital or a local community centre setting up a small 3D printing farm and producing face shields on demand. It cuts out all the shipping delays and dependence on centralised factories.
And that's the cool part, right? It empowers individuals and smaller organisations to become manufacturers almost overnight. Talk about a pivot.
Exactly. 3D printing provided a means to quickly prototype, iterate on designs, and produce small batches of products in response to immediate needs. It was a game changer during those early months of the pandemic.
It's like the maker movement went from a hobby to an essential service in the blink of an eye.
Pretty much, and these papers we are looking at today really highlighted how that rapid response took form.
Okay, so how did these researchers actually figure out what was going on with 3D printing during that crazy time? What was their approach?
Good question, Emma. They had to figure out a way to capture a real-time global challenge. So they went with a mixed methods approach, looking at news media, social media, and other sources of information that were popping up as things unfolded.
Makes sense. It's not like they could just send out a survey or something, right? It was all happening too fast.
Exactly. The first phase was a broad search using Google. They used keywords like 3D printing, COVID-19 and coronavirus. One of the limitations was, of course, being limited to Western search terms.
And they set a date limit, right?
Yeah, they only included results that appeared before April 1st, 2020 to really capture that initial surge in activity. This study captured what happened as the virus went global, but only during the initial stages.
Smart. So they're trying to see what happened in those early days as people were first reacting. What was their criteria for what to include?
The big one was that the product had to be end use. They weren't interested in projects that were just using 3D printing for prototyping. Also, it was key for the project to be health or medical related.
Okay, so actual face shields and masks, not just someone experimenting with a new design. What about the second phase?
The second phase was more targeted. They took the companies and projects they found in phase 1 and did deeper dives, searching for more details on their websites, social media, all that kind of stuff.
Like detective work?
A little bit. They were looking for things like blog posts, news stories, company announcements, anything that showed the project had origins before April 1st.
And if they couldn't find proof it started before April 1st, it got excluded?
Exactly. They also required documentation outside of just 3D printing file sharing communities like Thingiverse. They wanted something a bit more solid than just a file upload.
So a bit more validation that it was a real thing, not just a cool idea. I see. So it's a thorough, but also necessarily limited snapshot of a moment in time. What were some of the limitations of this approach?
Well, relying on Western search engines and English language sources definitely introduced bias. There was likely a lot of activity happening in other parts of the world that they just couldn't capture.
Right, language barriers and different internet landscapes would definitely skew the results.
Also, tracking projects through fluid mediums like social media is always tricky. Projects could have started earlier than they were reported online, or have been changed since their initial upload. Despite this, the authors put together two really cool data sets.
Got to work with what you've got, right? Sounds like a reasonable approach given the circumstances.
All right, Emma, so what did all that detective work turn up? What did they discover about how people were using 3D printing in those early days of the pandemic?
Well, the first big finding was that the vast majority of 3D printing efforts were focused on personal protective equipment, or PPE.
No surprise there, right? Everyone was scrambling for masks and shields.
Exactly. The study found that 60% of the projects they identified were making PPE. And within that category, face shields were the absolute king. They accounted for like 62% of the PPE projects.
Face shields, huh? Makes sense. Probably relatively simple to design and print compared to, say, a complex ventilator part.
Precisely. They're a great example of a design that balances effectiveness and manufacturability. The head-worn frame could be 3D printed, and then a clear plastic sheet would be attached to the frame.
So not the entire shield 3D printed, just the frame?
Exactly. That keeps the 3D printing focused on what it's good at, creating complex shapes, and avoids wasting material on a transparent surface. Think of it as an additive and subtractive manufacturing hybrid.
Clever. What about the actual printing technology? What machines were people using?
This is where it gets interesting. The dominant technology by far was fused filament fabrication, or FFF.
FFF? That's like your standard desktop 3D printer, right? The kind you might have at home or in a school lab?
Exactly. The researchers found that FFF accounted for the vast majority of the projects. It's relatively cheap, accessible, and the patents had expired, so there was a proliferation of competing products.
So not fancy industrial machines, but the trusty home printers saving the day.
It really highlights how accessible 3D printing has become. It's not just for big companies anymore. The maker movement really stepped up.
Speaking of the maker movement, what role did online collaboration and open source designs play in all of this?
That was huge. The researchers noted that a dedicated website was the most popular means of centralizing and reporting information. So people were creating websites just to share designs and coordinate efforts. It shows how a crisis can really spark innovation and collaboration.
That's awesome. So it was about open source designs?
You got it. These designs were downloadable for free, so anyone anywhere could start printing. People were remixing and improving on each other's designs at a crazy pace.
The power of the internet.
Indeed, it really shows how a distributed collaborative manufacturing system can emerge organically in response to a crisis. Okay, Tom, so we've talked about the types of PPE people were making and the technology they were using. But did the researchers dig deeper into the designs themselves? Like, how efficient were they really?
You're talking about the nitty-gritty details, the kind that separate a good design from a great design in terms of manufacturability.
Exactly. The second paper really dives into the quantitative analysis of those face shields and masks. They looked at things like print times, how much material each one used, the geometric qualities, basically everything you'd want to know if you were trying to optimize production.
So were there big differences between different designs?
Huge differences. That was one of the key takeaways. Even for similar designs, the print times could vary by several hours.
Wow! A few hours per print, especially if you have a large number of items being printed at once, could add up.
Exactly. That means some designs could be produced in much higher volumes than others. The researchers found that face shields were, on average, about twice as fast to print as face masks.
Aha! So that reinforces why face shields were so popular in the initial response. Speed and efficiency.
Absolutely. And they also used about half as much filament, which means lower material costs. Plus, face shields typically only required 1 or 2 parts to be printed, whereas face masks often had several.
Makes sense. The fewer parts, the less assembly required. Were they able to tell if any of the open source designs were more efficient than others?
They did. The analysis really highlights how important design choices are. For example, some of the more efficient face mask designs were 2.5D prints, meaning they were printed flat and then folded into shape.
Clever, like origami for PPE.
Totally. The main takeaway here is how open source can work in practice. All the designs being online meant others could rapidly iterate the designs for increased speed, reduced material cost, and more.
All right, Emma, so we know people were making PPE, we know what they were making it with, and we have a sense of how efficient some of the designs were. But what about the regulations and ethics of all this? It's not like you can just start mass-producing medical devices in your garage without anyone raising an eyebrow, right?
Exactly, Tom. That's where things get tricky. During the initial crisis, speed was the name of the game, and that meant a lot of traditional regulatory oversight got, well, maybe not thrown out the window, but definitely fast-tracked or bypassed altogether.
So what kind of ethical questions came up?
A big one was validation. How do you ensure that a 3D printed face shield made by a hobbyist is actually providing adequate protection? There wasn't always a clear answer.
I can imagine. I mean, just because something looks like a medical device doesn't mean it meets the necessary safety standards.
Exactly, and that puts a lot of pressure on the healthcare workers using this stuff. They're already on the front lines of a pandemic. They shouldn't have to worry about whether their PPE is actually protecting them.
So what did agencies like the FDA do? Did they just throw their hands up and say, "Good luck, everyone"?
Not exactly. They tried to adapt. The FDA, for example, issued some guidelines and collaborated with organisations like the National Institutes of Health to provide resources and evaluation platforms.
But it sounds like they were playing catch-up.
Absolutely. The regulatory bodies were definitely behind the eight ball because the solutions to COVID-19 preceded regulation. The maker community was moving so fast, and the traditional regulatory pathways just weren't designed for that kind of speed. I mean, how could the FDA keep up with the 3D printing of medical devices from home printers? It was likely impossible.
So it was kind of the Wild West of medical device manufacturing for a while there.
In some ways, yeah. A lot of good intentions, a lot of innovation, but also a lot of uncertainty and potential risks. So, Tom, taking all of this into account, what are the big lessons learned here? What can we take away from this experience of 3D printing during COVID-19?
Well, Emma, I think the biggest takeaway is that 3D printing really demonstrated its potential as a tool for localised manufacturing, especially during crises. It proved that you don't always need these massive centralised factories to produce essential goods.
Absolutely. It showed how quickly communities can respond to shortages when they have access to the right tools and the know-how. But it also highlighted some crucial gaps.
Like what?
Like the need for better design standards. We saw so many different designs for face shields and masks, but not all of them were created equal. We need some kind of baseline criteria to ensure that these products are actually effective and safe.
And that ties into the regulatory framework we were talking about earlier. We need to figure out how to adapt regulations to this more distributed model of manufacturing without stifling innovation.
Exactly. It's a tricky balance to strike. And then there's the issue of workforce development. We need to train more people in 3D printing and design so they can contribute to these efforts in the future.
So how can this research be used to prepare for future pandemics or other supply chain disruptions?
Well, I think it provides a roadmap for how to mobilise the 3D printing community quickly and effectively. It also points out the areas where we need to invest. Better design tools, clearer regulations, and a more skilled workforce.
It's like we've learned a lot about the potential of 3D printing, but also about its limitations. We know it's not a silver bullet, but it can be a valuable tool in the toolbox.
Precisely. And I think this research can help us refine that tool and make it even more effective for future crises. It showed the advantages of open source designs and rapid iteration, which can quickly adapt to real-world needs. But more importantly, this rapid adaptation would not be possible without the maker and DIY communities, who often went uncompensated for their efforts and likely will not have the resources to continue making and improving designs.
So it's not just about the technology itself, but also about the community and the infrastructure that supports it. The COVID response might be a good opportunity to provide resources to these communities so that their work is ready to use next time.
Exactly.
Well, Emma, that pretty much wraps up our deep dive into the world of 3D printing during the COVID-19 pandemic.
Yeah, it's been quite a journey from the initial scramble for PPE to the amazing ingenuity of makers and manufacturers around the world.
Absolutely, and hopefully our listeners now have a better understanding of the power and the challenges of this technology.
We encourage you to check out the research papers we discussed today. We will be sure to put links in the show notes. They're packed with even more detail and data than we could cover in this episode.
And if you're interested in getting involved in 3D printing or maker communities, there are tons of resources online. America Makes and NIH are great places to start.
Thanks for tuning in to Podcast My Paper. We hope you enjoyed the episode, and we'll catch you next time with another interesting research deep dive.